Good morning, everybody. My name is Antonello Monti. I'm professor at RWTH Aachen University in Germany. And with this module, I would like to give you an introduction to the energy transformation and how this process is influencing the operation of the electrical grid. In particular, what does it mean, digitalization, for the distribution system operator? How the whole process of digitalization, which is embedded in the energy transformation, is going to change the way distribution system operators are going to work. You may say that for about 100 years, nothing really big happened in power system. We established the grid as an electromechanical systems at the end of 1800, and since then we have been evolving the concept, but not really transforming the concept. Only recently, with the growing presence of renewables, we have a new kind of grid because of power electronics. Power electronics is bringing digitalization inside the network. And if you think about it, all the key devices that are connected that will be connected to the future grid are going through a power electronics interface. This means, for example, photovoltaic units, wind device, other electromobility vehicles, or heat pumps. All of them introduce an interface based on power electronics. This transformation means the system is becoming intrinsically digital at a lower level, but it also means we have a lot more flexibility and controllability in the grid because everything becomes a programmable system. All those new devices are also connected at the distribution level. And this is really the point where you really understand how the situation is significantly changing for distribution system operator. This transformation is reflected also in recent legislation of the European Commission, so the so-called Digitalization of Energy Action Plan, in which we identify 5 pillars: creating a European energy data space, empowering citizens, enhancing uptake of digital technologies, enhancing the cybersecurity of the energy sector, and creating the condition for green ICT. If you look at those 5 pillars, we can see that digitalization is transforming radically the system, starting from the customers, to the role of the customer, the interaction, and in particular, we're dealing with the role of data in the future of the system. In reality, when we try to visualize the process, we can say that the transformation is mostly creating a complete new role for the edge of the grid. All the new devices I mentioned in my previous slide are connected at the end terminal of the system, in the low voltage at the customer premises mostly. And this is completely transforming the architecture because now the bottom part of the grid becomes the key part. And that's why we can see that the energy transformation means transforming from a top-down system to a bottom-up. And that is clearly affecting the role of the distribution system operator that before was at the terminal, now being at the terminal becomes the core around which we build the infrastructure. And that means that to actuate this transformation, distribution system operator must be able to interact with multiple data interfaces. And here I try to summarize in this slide some of them because we'll have, first of all, data exchange bidirectional with customers. This is what smart meters are bringing to the systems. Of course, they are data collected from their own sensors, but there are a lot of interfaces that are external to the DSOs. That means collection of data coming from renewable energy sources, data exchange with transmission system operator. There is a complete new relation between the 2 levels of the grid that we need to establish, the role of new market players like the aggregators, and of course, data exchange internally for business process, and exchange with completely external to the energy system as well, like weather providers or data coming from other infrastructure, e-mobility, first of all. If we try to categorize, we can see that I, here in this slide, define 4 main categories. This means the internal business operation, mostly related to grid planning, the not energy-related data flow, like I mentioned, for example, weather-related, market-related interfaces, for example, aggregators, and internal infrastructure related TSOs, first of all, grid monitoring control, renewable integration. For all those data streams, we need to think a new concept of data management and then an architecture of platform. We can identify some requirements, some challenges in this process. The data approaches must be scalable. We are talking about a massive input of data because we will have millions of devices connected to the system. The solution must be open and flexible because the process is going on right now. So honestly speaking, we don't know all the requirements today. We are learning by doing. Solutions should be modular so that we can do this process incrementally. And we need a compatibility with legacy system because some level of digitalization was already there before, and we don't want to just throw away what has been done before, what it works. There are challenges because we don't have a single solution fitting all the requirements. Honestly, it's a massive transformation, cultural transformation, so the DSOs need to adapt to become a digital company. And of course, last but not least, we cannot forget that there are risks connected, and in particular, that's what is everything related to cybersecurity. And if we structure again a little bit more this data flow, I can identify two major layers. There is one layer here that is the top layer, which is the business operation layer. These are the slow process. They don't have a real-time requirements. They deal on the other side with massive amount of data. And they are more general purpose. The use case we consider at this level are not so specific for energy systems and then can exploit development and work done in other contexts. So that means we can use wider applied standard and we can use open solution. One possibility is the whole work done in the context of the FiWare platform. When we go to the DSO technical platform, so the more operational related, here we are dealing more with data stream that can be real-time or quasi-real-time, and then where we come to be more application-specific. And then we have to focus on standards that are specific of electrical systems, but again, we need to be open, and that's where activities like the Linux Foundation Energy are a great support to identify open source components to build a stack that works for distribution system operator. And as last but not least point, as I mentioned before, the interface to legacy system is critical for the continuity of operation and for a smooth process of transition. In the project Platone, we identify Platone is a Horizon 2020 project, which is behind this set of seminars, that we identify a key platform architecture. The approach we propose is a two-layer systems in which we have at the lower level a blockchain access layer, and then through this the possibility of dual use of data on one hand for market-related purpose so that every customer can participate to markets, and the other hand data can also be used for operation. Last but not least, the Platone architecture fully supports the integration of legacy solutions, and in that sense is a perfect way to transition to a new situation without a shock in the operation. You can better see those key interfaces in this new visualization. You will hear in another model later more details about the architecture and the overall Platone framework as an idea, but here I just want to remark in the core, the so-called DSO technical platform that we envision implemented by means of the Sonio platform, which is a project in the Linux Foundation Energy, and the three key interface, the market platform, the legacy systems interface, and the blockchain for customer inclusion. As I mentioned, a key point behind this vision is to adopt open source and open solutions. Why is that? For a variety of reasons. First of all, it's a matter of economics. Open source allows this process to be economically feasible because we share the cost of development instead of centralizing costs in a single entity. It allows the DSOs to be more in control of the process and managing this flexibility of modularity instead of being locked into a simple closed solution, massive application, old standard type of solution. Open source is also a more secure solution connecting to cybersecurity because we have multiple eyes, a variety of people looking. Is not just a two eyes type of check on possible software flows. That's a counterintuitive. Many people think about open source as less secure. Actually, reality proved already that because of this cooperation, we increase the reliability and the quality of the software we are implementing. The Linux Foundation Energy is, in this respect, a great reference. Here you see the list of companies that are actually involved, the company being doubling in just 1 year in terms of membership, reaching now more than 70 entities across the world. And you can see there is a variety from utility to large software companies to service companies, university research centers, all working together in a single platform direction. And this is structured in a set of projects, and in particular to reference to the topic of our webinar here, important to see in the level here in the architecture how the Sonio project is positioned in this multi-layer structure. In conclusion, I quickly showed you how the digitalization is completely transforming the energy sector and the role it plays. There are new options and possibility at every level. It's a full transformation from the hardware to the higher level of software. It means that we have opportunity for new concepts in operation, and they are going to completely transform the grid. We are just at the beginning of this process, and the digitalization is opening up those opportunities. But to make this possible, we need to stick with open standard and open solutions to have the flexibility to adapt the process while we are learning in this journey towards a fully decarbonized society. Thank you for your attention.